From inline product quality control to the traceability of packaged goods, the food and beverage industry has long leveraged instrumentation and control technologies to fulfill society's nutritional needs in ways that are simultaneously efficient, safe, and scalable. But food and beverage producers are being asked to do more with fewer people, to anticipate and prevent potential disruptions to production, and to advance the overall sustainability of their operations. And the COVID-19 pandemic has only brought added pressures to bear. But suppliers of instruments and controls are once again answering the call. Hello, this is Keith Larson. I'm editor of Control Magazine and ControlGlobal.com. Welcome to this Solution Spotlight episode of our Control Amplified podcast, sponsored today by Endress+Hauser. With me today to talk about how instrumentation and controls are addressing the changing landscape of food and beverage industry needs is Ola Wesstrom, Food and Beverage Industry Marketing Manager for Endress+Hauser USA. Welcome, Ola, and a real pleasure to chat with you today.
Yeah, hi, Keith. Thank you so much for having me on here. Really looking forward to this little conversation.
Yeah, me too. Clearly, the pandemic has only made it more challenging to really find, train, and retrain the skilled people that food and bev companies need to ensure that production proceeds smoothly. How would you say instrumentation technology is helping these manufacturers fill that gap?
Well, I'm not sure if technology is necessarily filling the gap, how to find and retain skilled workers. That's obviously a bigger task, to do
True.
that. But
Yeah.
Having that said, some of the tools that manufacturers are providing today to help educate, either through self-directed learning or maybe training for on or off-site, has really evolved a lot in the past couple of years, and it was really accelerated during the last 2 years here when access and let's say that personal touch was limited. But taking advantage of we're all part a little bit of a YouTube generation where online videos or remote directed learning can really help people that have let's say long skills, but also people that are coming on board to get up to speed as quick as possible.
Yeah, that makes a lot of sense. And certainly fewer people can be next to each other on the packaging lines, especially early on in the pandemic. So that really accelerated the need for that also. Are you seeing also more automation being deployed to address the fact that there's less manual labor being involved in the area of the production lines?
Oh, absolutely. There's no doubt about it. I mean, we've seen obviously for many years the application of robots, and other type of tools for packaging and machinery and so on. And I would say it's moving up in the let's say the liquid processing side as well, where you have operators that are running a line that are being asked to do more things, to monitor more things, and maybe even replace certain things, if they go wrong, as to place less tax on, let's say, the maintenance staff. So that is definitely coming there, and it takes quite an effort to get to that point. But there are technologies available today to make that easier. Some of those could be like the usage of wireless LAN technologies. We have started to apply Bluetooth connectivity for the instruments, which makes it easier to troubleshoot, configure devices, and then that can then help reduce any downtime and making it easier for operators or maintenance technicians to get their problems addressed as quick as possible.
I imagine that's especially important in classified or hazardous environments where you don't want to open up the instrument. A wireless connection is going to be much safer in those kind of situations as well.
That's for sure, yeah. Fortunately, we don't have too much of hazardous areas in food production, except once you get into maybe some flavor rooms or obviously in the distilleries, you may encounter some of that. But still, not opening up the enclosure or even a cabinet or getting access to it, maybe not so much an issue for hazardous area, but also to protect the equipment from the washdown that you have in food industry all the time. I mean, there's water and condensation and moisture everywhere. So anytime you can avoid opening a housing is one less risk of moisture or water getting in.
Yeah, that makes a lot of sense. And there's also the occasional powders and such that can make explosive combinations
Sure.
in bins and stuff as well. Not so common in the production environment, but certainly in the silos and things like that. Yeah.
Oh yeah, I don't know. That's it. It happens in bakeries and pet food facilities and other areas where you deal with a lot of powders, which you always have to be careful with from an explosion hazardous perspective.
Yeah. You mentioned maybe somewhat less skilled technicians working on the lines, and combining that with increased demand for prepared food and beverage products seems a recipe for downtime, especially if some of the technicians are not used to the warning signs of equipment stress, as it were. What sorts of digital tools are being deployed to keep an eye on asset health and head off problems that could affect production?
Yeah, there's a lot of things going on there. It's a really good point you're bringing up. I've talked to a large number of processors in the last year and a half, just to figure out, how are they adopting to, let's say, the COVID, which we're in right now, which has put a lot of strain. On one hand, you have the production need for the retail sales, which is through the roof. So they're trying to supply and keep the supermarket shelves filled.
Right.
So that's been a challenge there. And on the same time, having fewer people, and now we're dealing with a little bit of supply chain issues on the equipment side as well. Right. And one expression that I've heard more in the last 6 months that I think I've heard in my entire career is the expression of running to failure. Yeah. And I find this quite worrisome. Now, clearly, there's the balance of how you handle unscheduled downtime versus preventive maintenance. But that, let's say, maybe I don't know if it's a realization or maybe it's where people find themselves, to get into that mindset of running to failure, how to make up for that when you have a lot of, let's say, production or orders to fulfill and suddenly you have run to failure. Yeah. So I think you mentioned asset health and asset health monitoring. I think there's a little bit of a lack of awareness on how advanced diagnostics in today's instruments, well, not only in the instruments, but in control systems. You look at the diagnostics of valve and valve tops, motor drives, and others. There's a lot of things in there that can give an early warning. Right. If an instrument or whatever the device it is, if it is seeing something that is out of the ordinary, which could be either be due to the instrument or the device or process-related problems, right, which can really help reduce any unscheduled downtime.
Yeah, I'm surprised that you're hearing that run-to-fail methodology. I thought we were moving away from that as an industry with all the diagnostics that we've been working on for decades now. But I understand they're under pressure. Yeah.
There is a lot of pressure out there, so it's been quite surprising. That's why I've asked that question many times, because first couple of times I heard it, I was like, I thought, to your point, I thought we were beyond that, but we've maybe due to the pressures of the market today that we've kind of fallen back a little bit, and I think there's definitely opportunity to help bring that awareness out that it doesn't have to be that way.
That sounds good. That same skills and resource gap is also driving end users to rely more on third parties like OEMs to keep production lines running. Do you find clients calling on you to fulfill those services? And do you see any disconnects between the wants and needs of the users and priorities and what services are being provided by the OEM community?
There is a bit. I mean, this is not a new, but it certainly is a challenging topic, where on one hand, you have the CapEx, the capital expenditures that need to be balanced between the cost today and future operational costs. Right. And on one hand, OEMs, plant builders, suppliers, integrators, and so on are being asked to provide more and more for less. So often the focus then falls on the short-term CapEx budget, which has been available. From what we've seen is that this in turn sometimes results in just the simplest or lowest cost instrument or device being applied to get the job done. Right. And of course there's nothing wrong with that, I mean, generally, that things will work real well, but there are certainly times where it could become an issue where maybe accuracy or performance or reliability or like we mentioned earlier about the diagnostic tools, or the simplicity of operation, or just the digital integration of a device into a control system, could then lead in the future to production losses, rework, increased downtime, and so on. So I think that it's really best to try to really carefully evaluate the processing need, and then apply what is let's say the best fit to balance budget and technology there. And today those capabilities are there. Pretty much every supplier have entry-level, mid-range, and high-performance devices, so you can balance those requirements.
Yeah, it seems similar to the run to failure. It seems that looking at life cycle costs should be the accounting mechanism now for what actually can be performed with these instruments, but maybe not there just yet.
No, but I think we're close. I mean, if I'm looking at from my 20 years working in the food and beverage segment, I think we're making massive strides in the right direction here.
Yeah, absolutely. I know, Endress+Hauser, you have tools for doing augmented reality and really assisting your customers' technicians when they're there at the plant. How have those kind of tools been received by your customers?
I would say they're being slowly adopted, where people start saying it's like, okay, this is not as hard or not as difficult to adopt as we thought it was. People are embracing it. It's a little bit of hesitancy maybe in the beginning to apply it, or say, what else do we need to change in order to put this in here? But once people put those asset health monitoring tools into place, there's like, how did we operate before this? And generally we see it's like maybe start small, start in one area of a production facility, get a feel for it, and then after that add it on to other areas. And usually it's looking at where are, let's say, the critical processing steps. You don't have to apply that to every single device out there, because if they're not critical to an operation and you can run without that device and it's more providing additional information, well, you may not need to have that on a asset health monitoring type of environment.
Yeah, that makes sense. It's not just the food and beverage industry, but all the industries we're covering now are looking at having operators and technicians that maybe have a base level of skills, but they can't be expected to specialize in one area because they have to do multiple things. And they're trying to meet those requirements by having training plus technology assist to help fill the gaps in specific types of tasks. You seeing that as well?
Yeah, I see that as well. And I'll give you an example of, let's say, how this asset health can let's say, a scenario could play out. So you have, let's say, the asset health monitoring up and running. On one hand, you would have it connected up to the operator HMI. So let's say an operator running a cook kitchen or a line or whatever it might be, they have visibility to pumps, valves, instruments, measurement values, and so on, right? So that's usually what they see. They know what they mean. Right. Now on that HMI, you can then also say, okay, everything is running fine, everything is looking good. But if one of the instruments is starting to give you a warning and say, okay, seems like I'm starting to drift off a little bit here, or even worse, something has happened here, I'm out of commission, you cannot trust me anywhere. On that HMI, you can then have a red or a green light for the operator to see, oh, here's something seriously wrong here. This one has a yellow light on it. I can probably run my process, but I need to get some technician to come and have a look at it. If it's red, maybe I shouldn't even start my line because it may not be correct. I might be producing off-spec product if this instrument is not doing its job. Maybe my recipe will be off. And on the same time, in the maintenance shop, they have that same screen, but in a different way to give them an idea. Let's say you have 200 critical assets in a facility. You come in the morning, you say, okay, you have your screen. You see you have 195 that are green, everything is good. You have 4 of them that are in the yellow, and you have 1 red. Well, now you have your, let's say, your priorities for that morning outlined for you as you come into the facility. And no need to try to figure out or even wait for the operations to call you and say, hey, there's something wrong. You can just go straight to it and say, okay, what do we need to do to fix this?
Yeah.
So that's a scenario that this asset health can provide.
And your instruments and Endress+Hauser instruments actually have increasingly sophisticated ability to verify their own operation, even as far as self-calibrating in some cases as well. Can you talk a little bit about that functionality and how that comes to bear?
Sure. Yeah, some of it very specific to certain technologies and so on. But since you mentioned, say, the self-calibrating, that is referring to one of our temperature sensors, where through some really clever innovation, we came up with a way to have a fixed reference point built into the temperature sensor, so that every time the temperature crosses that particular point, the temperature sensor, the temperature transmitter, self-checks itself against that reference point. And if it starts noticing that it's drifted off by whatever tolerance you define, let's say if you define 0.5 degree, 0.2 degree, or 5 degrees, you can define at what tolerance are we still good here. Then that gives you an alert and say, okay, this temperature sensor have now drifted off. We need to replace it. Rather than, like many plants do, every 3 months they shut everything down and spend a lot of time going through and calibrating every single sensor. Now you only go fix the ones that are not working. So that's one aspect of it. And then on many other instruments, we have a diagnostic tool. We call it heartbeat technology, which is running a deep diagnostics of the instrument. Think about it this way. Say in your car, you have your check engine light, right? So the check engine light would be let's say the normal, okay, something is wrong. Some people just keep on driving. Others are more conscious about it and bring it to the shop. Right. So that's kind of a basic. Now, once you get to the dealer of a shop, then they hook up their diagnostic tool to really dig into, what exactly it is. They can tell you that it's the O2 sensor or this sensor or whatever it might be that needs fixing. Well, that's what we have built into the instruments. So that advanced level of diagnostic is built into the instruments. So that by generating or just initiating that heartbeat report, it gives you a document to say, okay, everything checks out. This instrument is still as good as it was when it was manufactured. You can rely on it and you can keep operating. Or if there's something it detects that, okay, 9 out of 10 or 20 out of 25 checkpoints is fine. There's one that looks a little bit suspect. Right. You may or may not have to do anything about it. Sure. So those tools are there.
That's great. Very, very clever. Very clever. On another front, like everywhere else, margins are getting squeezed for food and beverage manufacturers. Even though they're seeking automation and operational efficiency initiatives, stakeholders are still clamoring for sustainability through such measures as resource conservation, lower energy consumption related to greenhouse gases, and water reuse as well. Can the investments needed to advance those initiatives pay off on both sides of the equation, resulting in more profitable and more sustainable production?
Yeah, I think they go hand in hand. Certainly every situation has its own return on investment. Sometimes it might be, monetary return on investment. Sometimes it's, how do you use, let's say, carbon footprint, from a marketing perspective or other views, that is more consumer driven from it there. But I think, from an operational efficiencies, closely looking at where the suspected losses are, maybe energy, water, or just product losses. Generally, each facility have at least an idea where those losses are at. But I would want to give the, I don't want to call it a warning, but a heads up, like don't assume that because I've been involved in a couple of scenarios where there was a perceived idea that they were losing water in a certain area, but after a deeper dive into it, it turned out that area wasn't actually the problem at all. It was a completely different location of a plant where water was being wasted. And and was more operator related and shift related, which was invisible until we actually started measuring it.
Yeah.
So simple, let's say for waters, especially easy. Generally, there are flow meters somewhere in place, and if you don't know, then you can put a temporary clamp-on meter onto a line, and you can run that for a couple of weeks and see where things are going. So I would suggest the best way is to try to get real values wherever possible. And the same thing goes for, let's say, plants today do a lot of changeovers. They produce a large number of different type of products, which has resulted in more changeovers. Each changeover, there is a risk, or there's always going to be some loss of product or loss of water in between the different products. So to have a good phase separation sensor or a switch in between there can really go a long way to reduce losses.
Oh, that makes a lot of sense. So you're not spending as much time purging just in case. You actually know when things have been cleared out of the pipes. Yeah.
Correct. Yeah.
Gotcha. Another issue that I've been hearing about is food and beverage companies aiming to reduce costs through more standardization. How does this trend really affect end users' investments in instrumentation control technologies from your perspective?
Yeah, I think the largest impact is on operational efficiencies.
Okay.
Like we talked about earlier here, finding skilled workers can have an effect as well. But by standardizing, then you can potentially reduce the amount of spare parts. So you can then maybe not have a policy of running to failure, but if you do, you'll have the spare parts on hand, because you can't rely on getting spare parts in from somewhere. In an environment where 10 minutes downtime is too long, how do you justify waiting 2 days for a spare part to come in? So by standardizing, you can really tighten up the spare part inventory, and therefore also get back up to operational efficiency as quickly as possible. And to some extent, the first point we talked about, the training needs and familiarity, then also help reduce downtime if and when something goes wrong. The last thing you want to have is somebody trying to read a manual and figuring out how to set something up or even wire it up if it's the first time they see it. So having a standardization, you're speeding things up as well there. And some of the tools, let's say if you have the right tools to configure, or maybe you're standardized, so all your instruments and devices you have already downloaded and you have electronically on file all the configuration. So now when you do install a brand new device, instead of reading from a notepad written 5 years ago, you have a digital file with all the programming information in it, and you do a download that maybe take 10 seconds to download the actual settings into this new unit. And I think that all goes towards that standardization, that have the familiarity, have the data files in place to be able to quickly replace instruments when they fail. And an interesting point here, for well over 10 years now, we have assisted plants by what we call providing an installed base assessment. And you'll be amazed how often the IO count is underestimated by large factors. I mean, easily 10-20%, where people say, yeah, we have 300 instruments in our plant, and we go in and do an install base assessment, and we found out, well, you actually have 400 or 450 instruments in here. And we're like, oh yeah, we had no idea. I mean, it's like, yeah, we did that expansion 5 years ago, but that stuff 10 years ago, and somewhere along the lines, that documentation wasn't tracked, or instruments got moved from one location to another one. Nobody knows where they're at. It has a tag number to it, so that there's something there, but what the actual device is, nobody really knows. And then you run into scenarios where things might have been phased out years ago, and you cannot get a replacement, or at least not a direct replacement for it. So now you are kind of scrambling to find the part or something similar, and in order to get back on track again there. So all that kind of drives towards the importance of standardization, so that you have as few parts as possible, you have a clear migration path, and your people know how to install them and program to get up and running again.
Mm-hmm. And I imagine that's even more critical today with some of the supply chain issues that industrial companies are having along many fronts. Downtime when you don't know what you need to replace could really climb quickly, I'm sure.
Exactly. And then even if you do know what to replace, unfortunately, the supply chain
that too
have strange connections. If you start digging into it, like, why is this a shortage? Well, it turns out some not even connected thing is short somewhere else.
Yeah. Well, hopefully the days of dealing with that are coming to an end, that someday very soon. Let's hope that we get our supply chain issues worked out and don't have to at least deal with that additional complicating factor. So hopefully. Yeah.
I somehow suspect we might be out another 6-8 months before things really start settling down on that. But we certainly are doing our best to keep our supply chain as uninterrupted as possible.
Well, great. Well, good luck with continued success on that front. Thanks again so much, Ola, for sharing your insights with us today. We're kind of coming up to the end of our allotted time. Thanks also to Endress+Hauser USA for sponsoring this episode. My name is Keith Larson, and you've been listening to a Control Amplified podcast. My guest today has been Ola Wesstrom, Food and Beverage Industry Marketing Manager for Endress+Hauser USA. Thanks so much, Ola. Really appreciate it.
Thank you so much.
And finally, thanks to you, our listeners, for joining. And if you've enjoyed this episode, you can subscribe at the iTunes Store or at Google Podcasts. Plus, you can find the full archive of past episodes at controlglobal.com. Signing off, until next time.